Hi, so welcome to Tech, a lesson on VoIP, okay, class of service for VoIP. Now, this presentation is going to be pretty quick actually. We'll go through the main parts of it as we configure it. But what I wanted to do is I just wanted to give you a very brief overview of the DSCP, the diff serve code points, with regards to VoIP and why we have to do certain things when we're testing. Okay, so the diff serve code points, DSCP, which the VoIP will utilize. So it's just going to be a very small presentation. Okay, so DSCP, just so that you're aware, it utilizes the first 6 bits of the 8 bits in a byte. So SIP voice is DSCP 46 and RTP is 26. So that would be seen as follows. Okay, so the normal 8 bits of a byte in binary, as we know, is the 8 bits from left to right is 128, 64, 32, 16, 8, 4, 2 and 1. So if we take the first 6 bits from the right to the left of 1, 2, 4, 8, 16 and 32, that's what DSCP utilizes. Okay, so the DSCP, 6 bytes in binary, 1, 2, 4, 8, 16 and 32. So what's SIP 46 in binary? Well, we know 32 plus 8 plus 4 plus 2 equals 46. So it's actually 101110, and you'll see that in a lot of coding. Okay, RTP is 26, so it's 16 plus 8 plus 2. So that's 011010 equals 26. So under normal operations, when you have a device that's transmitting SIP and RTP as DSCP 46 and 26, like a lot of modern phones do, then the above is all good. You know, you don't have to change anything within the config that we're going to show you in this lesson. But it's important to note that when ping testing, Juniper utilizes all 8 bits of the byte and not 6. So we have to move everything to the left by 2 bits. So the DSCP now becomes the following. So remember, this is only for ping testing, to ensure that you've got your queuing correct. Okay, so when you do a ping test, we now see it as 101110 has been moved 2 over to the left with 2 zeros at the end. So now the 1, it's 128 plus 32 plus 16 plus 8 equals 184. For RTP, moving it 2 over to the left becomes 64 plus 32 plus 8. Okay, so, and that equals 104. So when completing the ping test to check correct queuing and classifications, you've got to remember to utilize the following. On Juniper systems, ping, type of service, so it'll be ping TOS, and instead of putting 46 in there, you're going to have to put 184. And for SIP, 104 instead of 26. Okay, that's for RTP. Like I said, if you've got a phone and you're testing with a phone, you won't need to do this because the phone will do the test for you and check the classifications and the queues. Okay, so now that we've got that lesson out of the way, that very quick bit of presentation, let's get on with the actual configuration work. So from a topology perspective, we are going to utilize the same topology as we utilized for the MPLS layer 3 VPN. And the reason for that is because continuing onward lessons are going to be around RSVP with MPLS and layer 3 VPNs. So that's going to require class of service anyway. So as we're going to require that for the forwarding lessons, we may as well just utilize this network. So what we're going to do is we're going to put the class of service on the provider edge for site A, and we're going to ping from London customer site A to the loopback address of the P router. So the ingress interface for the class of service will be GE000, and the egress will be GE005. Okay, so let's go ahead and complete the configuration on the provider edge. So the first thing I'm going to do is I'm going to log on to the London customer, and I just want to show you that it's a basic configuration. What I've done is I have removed any BGP, any reference to that, because I just want to show you the class of service for now. Okay, so as you can see, it's a very basic configuration. Pause the video at this point and have a look at that configuration. The P router will still have the is on it, and possibly some of the other configuration. I don't think I really removed much from this because there was no need to on this one. And again, just pause the video if you wanted to have a look at the config on there. Okay, again, very basic configuration. So now we go to the provider edge router. And again, I'll just quickly show you that I've removed all the MPLS, BGP, etc., because I want to concentrate on the class of service for now. Okay, so it's a basic configuration there as well. All right, very important to understand before we start this, that this will require, there is a command that will require a start of the egress interface FPC that it's located on. So if you're going to be doing this in a live environment, I suggest a maintenance window because of this reboot of the or restart of the FPC. With that being said, what we should do now is we're going to start the actual configuration work. Okay, so that's what we're going to do now. And the first thing we're going to look at is we're going to look at configuring our drop probabilities. Okay, if you want to know what all this isn't a class of service tutorial. This will work perfectly well for voice. Just change certain things as to how you want them to be. Okay, so let's do a set class of service, our drop profiles. Okay, and we're going to call the first one low drop, and we do a minimum and a maximum. So there's 2 for each here, and our fill level 95. So once it's 95% full, what's the drop probability? Well, we actually don't want any drops really as such, so we're going to put a 0 in there. Okay, and then our higher level we're going to put as 100. So our drop probability on this is going to be 100. Then we do our medium drop. So we do a medium drop, and we do our fill level again, and this time we're going to start on 75, and we're going to do a drop probability of 0 again. And our upper level on this is going to be 95 with a drop probability of 30. Okay, now we need to do our high drop and our fill levels, and we're going to start on 50 with this, and our drop probability we're going to have as 0, and our upper level we're going to have as 95 with a drop probability of 50. Okay, that's our drop probabilities and our drop profiles created, so we can commit that. Now what we're going to move on to is the schedulers. Within the schedulers we actually call the drop profiles that we've just created, so they're linked together, and you'll see this working as we go through it. So let's do a set class of service. Be careful to type schedulers because there is a scheduler command there as well. This must be schedulers. BE, best effort, we're going to deal with, and we're going to do a transmit rate percent. This is percent of the bandwidth 65 that's available on the egress interface. We're going to put the buffer size to be the same. So the buffer size is also completed as a percentage, and we're going to put that as 65. And the priority is going to be medium low. So we're going to put a priority of medium low on there. Now we have to set our actual schedulers themselves. Okay, so let's go ahead and go back to our BE and our drop profile map. So we're configuring the drop profile map within the schedulers now, and the loss priority is high. Okay, and the protocol is going to be any. Okay, and the drop profile that we've just created above is our high drop. Now we go to our medium. So we've got high, medium low, and low. So now we go to our medium high. Okay, our protocol is any, but our drop profile this time is going to be our medium drop. Okay, so we put in there medium drop. Now we can go to our medium low, and that's also going to be a medium drop, so we can just enter that. And now we're going to go to our low. Okay, and we're going to put the same in there. This is a little bit tedious, this section, but unfortunately it does have to be done. Now that's our best effort queue completed. So next up comes our network control. Okay, so we're going to put in there again our schedulers, NC for network control, and our transmit rate. This time as a percent, only needs to be small, so we're just going to put 5 in there. Our buffer is going to be the same size. Oh, sorry, that's got to be a percent there. And our priority for this is going to be medium high. Now we have to do our drop profile maps again. So the laborious bit, but it has to be done. And our loss priority, and again it starts at high. Our protocol any, and our drop profile again is high drop. Okay, now we go to our medium drop, medium high, sorry. So in here we can put our medium high, and our protocol is any, and our drop profile is going to be our medium drop. And as that's going to be the same for the low, we can just go back to here and we'll put in low. And we also have our low. Okay, which we then put in our low drop. Okay, that's our network control. Now we're going to do our expedited forwarding, which is going to be slightly different. Okay, on this particular one, it's going to be a little bit different. So our schedule is now going to be EF, and our transmit rate. This time we're actually going to put in 5K. So we're actually going to put this in bytes. Okay, we want the transmit rate to be exact. It has to equal 5K exactly. Okay, and our buffer size is going to be temporal this time. So we'll have a quick look. So let's put a question mark, and it's temporal. Buffer size is temporal value. Look up what the temporal side is, but it's basically telling us again, don't go over. Okay, so our buffer size is temporal, and we're going to give it a value of 1. Okay, now we have to do our drop profile maps again, starting with high, and our loss priority is high, and our protocol is any, and our drop profile is high drop. Okay, now we can go to our medium high this is. So let's just put that in here, medium high, but our drop profile is medium drop. And we know that our low is the same, so we can do our medium low, and we can just enter that, and then we can do our low, but we must make sure that we change the drop profile to low, to a low drop. And that's our expedited forwarding. Now we're going to do, we're going to have renamed a different queue for the next one. It's going to be called SIP voice, so that we can differentiate. And I'll show you how to rename the queue. So we're going to actually call this one SV. Okay, so this one is SIP voice, and the transmit rate is going to be what's left percent-wise. So we're going to put 30. So we're going to have 30% in there for the transmit rate, and the buffer size is going to be the same as a percent. And the priority on this one is going to be high, because this is our voice traffic. Now we have to do our drop profile maps. Okay, so let's go ahead and do those. Our drop profile, loss priority, And again, we start with high, and our protocol is going to be any, and our drop profile is going to be the high drop. We're now going to do our medium high. So let's change this to our medium drop. Let's get rid of that. Sorry, I accidentally pressed the enter key there. So it's the medium drop, and we need it as medium high. And as the low is also the medium drop, we can go on there and configure that. And the actual low itself, we need to get rid of this. And we go back to the drop and we put in the low. Okay, so that's all of our actual schedulers completed. So what we're going to do now is we're quickly going to change the forwarding class of Q2 to SIP voice. Okay, so let's do a set class of service, and it's the forwarding classes, and we want Q2, and we're going to call it SIP voice. So we've just renamed Q2 to SIP voice. Okay, now what we're going to do is we're going to configure our scheduler maps. So we can do set class of service, and these are our scheduler maps, and we're going to call it normal. This is a scheduler map that we're calling normal. And as you're about to see, we're tying everything together now. So our forwarding class is going to be best effort, and our scheduler that we've just configured above, well, what's our best effort one? What did we call it? Well, let's do a question mark. Well, we call it BE. Look, there they are. They're all listed there, the ones we called it. So we need to put in here BE to say that is relevant to the best effort queue. Okay. So what's next is that we're going to have expedited forwarding. So in the expedited forwarding queue, the scheduler was EF. Okay. Next up, we're going to do the SIP voice, and it will be in there. So if we do the SIP, it's just that, and that'll give us it. And the scheduler we called SV. Okay, and for the network control, we called it NC. So the forwarding class is going to be network control with a scheduler of NC, as we called it. Okay, we can do a commit check on that. Okay, and that's fine. So let's commit that. Okay, so what we have to do now is we have to set within that class of service, and this is very important that we note this, the interface, the egress interface, we don't set this to the egress interface. We set the egress interface to the class of service. So we have to do that now. So let's do that now. Set class of service interfaces GE-005. Okay, and the scheduler map, that we've got is normal. So that's assigned it into the normal scheduler map. Okay, so let's commit that again. Okay, now what I'm going to show you is I'm going to show you how we view the queues. So run show interface GE-00. So we have to look on the egress interface, and we need the extensive command. Now normally you would see the queues in here. Okay, so we're going to go through this, and you don't see it. We do see the configuration here. Okay, but we do not see the actual queues themselves. All right, I'll show you why that is, but what we need to do is, do you remember I said about the command that requires the reset of the FPC? Well, because this is a virtual system, I know that there's only FPC 0, so I can do a set chassis FPC 0, and this is the command, flexible queuing mode, and we'll commit that. Okay, now it doesn't necessarily require a manual restart. It may do this from an automated perspective. So if we do a run show chassis FPC, currently at the moment you see it's now offline. Okay, if we were to do if we exit out of this and we do a request chassis FPC slot 0 restart, it'll tell us it's already restarting. You see it says restart initiated here. So let's have a look again at show chassis FPC. Okay, it's present at the moment, but it doesn't show us online, so we have to wait for it to come online. So let's just wait for it to come online. Okay, and there we go, it's online. Okay, so now what we can do is we can now have a look at show interface, the Egress interface, remember, extensive, and let's see what the difference is. Okay, so we're going to have a look at this interface again. Okay, so you notice now that we didn't have before, we now have the queues here, look. Okay, so this information here tells us our queue number and the forwarding class and their names. This shows us the amount of packets going through. Okay, so what we're going to do at the moment is we're just going to reset that. So we'll do a clear interface statistics GE-005. Okay, so we want to clear those statistics that are there at the moment. Okay, network control we'll always have coming into that queue anyway. Okay, because that's the is packets at the moment. So we've got 0 in the best effort, and we've got nothing in the SIP voice, which is exactly what we should see. So let's come out of that, and we're going to do our ping test now to London customer A. From London customer A to the P router loopback, which is 6.6.6.6. So let's have that running. We're going to go back to PE site A, and we're going to have a look again at the extensive. Okay, now we see some packets going into the best effort, and that's good. But that's not actually using the queues as per how we've configured them at the moment. It's all going to go into the best effort queue. And there's a couple of reasons for that. Okay, and the first one, let's just stop this ping again a minute. And the first one is we haven't yet defined our traffic. So let's go back to edit mode on the PE. So we need to define our traffic. So in other words, we're going to classify the traffic. Remember, we want DSCP 46 and 26, so for SIP and RTP. So let's go ahead and do that. So we're going to do set firewall filter, and we'll just call it COS. Okay, and we need to give it the term 1 from DSCP, surprise, surprise, 46 and 26. And where do we want it sent to? So we want it to go to forwarding class, funnily enough, SIP voice. Then we need to accept it. Under the same filter, we need to put in a term 2 because we need to stipulate the rest of the traffic. Any other traffic that doesn't match term 1, where does it go? It goes into forwarding class, best effort. Okay, and again, we have to accept that. So we've accepted that. Now let's place that on our Ingress interface, which is GE000. So we're going to do set interface is GE-000 unit 0 family inet filter input, because it's input and it's COS. Okay, we can now commit that. And that's that committed. Okay, now what I'm going to do is I'm going to show you what I mentioned in the presentation. So we're going to do a ping. we're going to do a type of service. There you go, TOS, type of service. And all it is a number that it's going to ask for there. So we're going to put in 466666. So we're pinging across again. Now what we've done is we're classifying our traffic and we're asking it to do DSCP type of service 46 via a ping packet, which we should see go into the queue. So let's have a look then. So run show interface G-005 extensive. What do we see going into our queue? Nothing. Okay, there's still nothing there. It's still going into best effort queue. Now, as I said in the presentation, the reason for this is because the 101110 is no longer under the 6 bits, it's the 8, so it moves 2 to the left and it becomes 184. So that 46, let's stop this and let's put this to ping type of service 184.666.6. Okay, so let's have a quick look at that. So let's have a look now at what we've got on the PE Egress interface statistics. Let's have a look at the queues now, and as you can see, we now have traffic going into Q2, which is exactly what we want to see. Okay, so again, let's do a very quick run. Actually, let's stop the ping test first, or we're not going to be able to clear the statistics. So run clear interfaces statistics G-005. Let's make sure they are gone before we do the next test, and they are. Look, so we're showing now as zeros again. So 104 will be the RTP traffic. So let's do a ping type of service 104 6.6.6.6. Normally it'd be 26, remember, the type of service, the class, the DSCP code points, but because we've got to move them 2 to the left, it becomes 104. So let's ping that again. Let's go back to the PE. And let's have a look at our statistics again, or our queues. And there we go. We have packets going into Q2 again. Okay, so that shows you the class of service and how it works. For the actual information regarding a class of service tutorial, I would look on Google for the moment, but I will be doing one. If you have any questions, please just let me know. Okay, hope you enjoyed that lesson. Thank you. Bye-bye.